Hi everybody, welcome back. So at the last part we got this thing to a semi-working condition, but obviously it would not test capacitors. And it was giving us an error 7, which was value out of range. And I said before that I think the next thing I want to do is try to go through the calibration. You can learn a lot about what's not working and what is working by doing a calibration procedure. Not just on these, but that's a good rule of thumb when you're trying to troubleshoot this stuff. So that's what I'm going to do. I've printed out the calibration procedure. It's actually not as bad as you might think. You do need some very specific values of inductors and capacitors and so forth, but I'm not going to worry a whole lot about that. I just want to see this thing work right now. If I need to get really ultra accurate components, I can sort through things that I have and find ones that are very close using some other pretty accurate test equipment that I have. Or, in the worst case scenario, I can order the couple of capacitors, and precision resistors and so forth that I need. But we'll get to that later. Right now, let's start out with the very beginning of the calibration, and that is where we're going to calibrate the power supply. And I have a feeling this is not going to be too far off, but we'll go through it. So let's turn things on here. And let's set up the meter. And they're essentially having you connect the ground, or connect the test lead, and they want you to use the ground lead for your ground reference for all of your measurements. So I thought that was pretty interesting. So we're going to do that. I'm going to connect that up down here. Turn on our meter. The first thing they're saying is to set up the 14.5 volts supply. Now I read through this and kind of familiarized myself with the board, and this unit here must be a little bit newer model than the instructions that I have here, because they're talking about going directly on certain components. And in some instances, you don't have to do that. There's actually a test point where you can connect your meter and measure with. So wherever that's going to happen, or wherever that is, I'm going to take advantage of that. But some places, you still have to follow the instructions here. It's still the same procedure, and everything's the same number, part identifiers and everything. But they just made a couple of changes like that. So the unit's turned on. I want to look at CR16's anode, so it's a diode, and CR16 is this little one right here on the board. And if you look at it, the anode would be right here, but you can see there's this test point TP1, and I checked it, and if you take the measurement here and take the measurement here, they're identical. Another thing we can do before we do anything, we'll kill the power, and I'm just going to do a continuity check from TP1, because they don't show it on the schematics either, to the anode of this here, and you can see it's pretty much a direct connection, with the exception of my poorly connected meter lead. So again, we can use that test point instead of trying to go in there. All right, back to volts, meter on. All right, and they're saying to set R40, which is this pot we're at right over here. They want you to adjust that until you have 14.5 volts, but as you can see, it's right on 14.503. And it's plus or minus 100 millivolts, so it can be 14.6 to 14.4. So that one's good. Next, they want IC6 pin 3. So we want to get over to IC6 pin 3. And that's going to be over there. Let me get set up. And again, instead of having to get onto the transistor, or the IC itself, or the voltage regulator, they have an actual test point, which is test point 2. So we're going to connect right on to test point 2. And they're saying they want 18, what are they saying? 18 volts plus or minus 0.1. So that one's off just a tiny little bit. So we're going to adjust. It looks like they're saying for the 18 volts, R53. So let's adjust that till it's right on 18. There we go. 18 volts. Okay. Now we want IC14 pin 2 on the 2000 board. So now we have to flip the thing over. And I'm going to shut power off to do that. Let me get the unit flipped over. I'll be right back. Okay, and on the 2000 board they want IC14 pin 2. So let me find that here. Give me a minute. I have to move the camera. Okay, IC14 is right here, and there is a test point, but it is not connected to that. So we want to be on pin 2, and we want to adjust R48, and it says to adjust it for 200 millivolts, plus or minus 1 millivolt. That's really pretty accurate. They want it. And look at that, 200 millivolts. All right, we would have adjusted this pot right here if that was off. IC27 pin 9, we're going to adjust for 1.7 volts. So IC27, let me move the camera, I'll be right back. Okay, they gave us a test point for this one again, and that goes to IC27 pin 9, and we're going to adjust R71, and we want 1.7 volts plus or minus 20 millivolts, and I'll buy that for $1. Okay. All right. Now it says connect the probe of the DVM to the red clip. So now they want us to take this and go over to here. And they want us to enter into the keypad 100 volts and push the capacitor leakage on the main board. So we're going to type in 100 volts. Let's see if I can show this to you here when I do it. 100 volts. Good, and this thing flashes telling us that there's high voltage going to be applied. And it says push the capacitor leakage button and adjust R201 for 97.5 volts. So let me find R201 before we do this. Okay, R201 is back here. It's this pot right there. So I'm going to hold this button down and adjust this. So let's see, 98.9, and they want what? 97.5, right? 97.5. Okay, so let's adjust this. Wow, that's touchy. How's that? 97.49. I'll keep that. Okay. Enter into the keypad 4 volts. So I'm going to hit 4 volts. And now I'm going to hit leakage, and I want it to say, and I'm going to adjust 205, which I think I saw that one. That's this one over here. We're going to adjust that one for 3.9 volts. And that's pretty close, and it's moving around a little bit, but I'm going to leave that one. It's funny that they have it go, you have it adjust it to be a little bit lower than the actual voltage. Okay, enter into the keypad 1 volt. All right, 1 volt. And do the same thing, and we're going to adjust R69. Let's see where it is. For 0.975, and it's jumping around there, but it's pretty close. I have a feeling that's kind of, you're getting way down there for that power supply. All right, so I don't have to adjust that. Now it says enter into the keypad 1.5 volts. So 1.5 volts. And it should be anywhere from 1.425 to 1.5 volts. And it is there. It's right there. Okay. Now we get into the capacitance calibration. It says short the leads and push the lead 0 switch on the LC-102. So we're going to do this, and I'm going to get just something, the random lead here, so I can have something to clamp them together on. These are hard to clip together directly. Clamp those together, and I'll hold this up so we can see what it does. And they're saying the first thing we want to do is do short, so we do the short calibration first. And I think that's okay. And then it says to open it, open the leads, and then hit open. Now that one chased across there, but the short did not. I don't know if that means anything, but we're going to find out, I guess. All right. Connect the test leads to a 1500 picofarad cap and adjust R55 for reading of 1500 picofarads plus or minus 5 pf. So let me see if I can find a 1500 picofarad cap, or at least something really, really close. All right, so I put together a hand-picked 1200 picofarad film cap and a 300 picofarad mica cap, and kind of sorted through what I had, and this is pretty much spot on 1500 picofarads, almost exactly to the number. So let's put that on here. Put this on here. All right. And what we want to do now, let's get the meter out of the way so we can work. I'm going to prop this up, and it looks like they want what did they say, R55, right? Yeah, R55, and that is right here. This is R55 right here. So let me get that, if I have to adjust it. And they want me to hit capacitor value, and it's 0 picofarads. Well, that's interesting. And this pot is maxed out almost. So somebody must have been in here messing with this. And I think this is the person that was servicing this prior. He must have been onto something here with that. So that has no effect, and it reads nothing. So let's do a little digging and see why that is. Okay, boy, this was convoluted. So if I go from the collector of TR11 to the top of R56, which was very hard to find. It's a 1.47 meg precision resistor. That resistor is all the way down here by IC23. By the way, this chip had been replaced by someone, and it looked all burned. It looked scorched when I took it out, before I took it out. So I replaced it, but it's obviously still not working. This is one of those TL084 op amps. But anyway, neither here nor there. If I go from that collector, where was I? I'm upside down. If I go from the collector here to the top of that resistor, I should be able to read this potentiometer, and indeed I can. And if I adjust it, I mean, it moves. And you can see it just keeps changing range here on us. And if I go to the range button, and we'll just use the bar graph, and you can see it works. So the pot is good, and for whatever reason it's not working. So I wonder if that transistor might be bad. Now I kind of just went on to diode check and checked it, and even though the voltage drop is higher than I'm used to, it's like almost 0.8 volts, that might be normal from base to collector and base to emitter, the forward voltage drop. But perhaps the transistor's not working, I don't know, or well, or somehow this thing's not finding its common, but it has to, because all of these are tied together to the same common point. And they find it through this TR15. So maybe what we should do is look at TR15 and see if it's being turned on. And I just moved that pot a little bit. Put it back to where I saw it there. Maybe we need to see if TR15 is turning on to bring that common point to those. You see, you have to have that or it won't work. So let's look at the base of TR15. And guess what I just found? This is TR15, and this is a replacement. I think it might even be an NTE replacement. No, it's not. It's a yeah, ECG 220. Yeah, this is an ECG replacement. So this transistor was replaced. I'm telling you, this guy that was working on this before me, he was on it. He knew what he was doing. I just wish he was around to be able to tell me, but well. Anyway, TR15, let's check it. Okay, this is a really strange transistor because the base is the middle pin. So it goes emitter, base, collector. Normally the base is on one of the ends and the collector is, you know, center pin, center tab. Alright, so I zoomed in on this a little bit and printed it out so that Mr. Magoo can see what he's looking at. And again, coming down to this 2N6559, this is kind of a strange transistor. This is a vertical driver transistor for television. And it's rated at 350 volts, and its minimum transition frequency of 45 megahertz, maximum of 200 megahertz. So this is a very fast transistor, and it's good for about 2 watts of dissipation. So not a very common transistor, and probably very difficult to find one of these. But again, this ECG, you can still find these, I'm sure, the NTE or ECG 120 or 228. And it's, as I said, it has been replaced, and I can see why the previous technician did that, because this has to enable these. So what's happening is we're turning these current sources on. So you can see you have 4 ranges, from 0 to 2 nanofarads, 2 nanofarads to 2 microfarads, 2 microfarads to 2,000, and then 2,000 to 2 farads. And you can see how those are all turned on by these gates here, which come off of this line down here and across and down. Okay, we could look at the big picture here later. But anyhow, these current sources are turned on, and then you set the current source by these pots. And of course, lower value capacitors are going to have a lower current source on them. And then the microprocessor and the firmware will turn this transistor on, and this is what provides the common point for all of these to come on. So there should be some kind of a signal here. Now I got to think this transistor is good because it has been replaced, and I think this is the area where that last person that was working on this was focusing, and I can see why now. Because what happens is when we hit that capacitor value button, it's supposed to apply the appropriate current source and then measure the time it takes to charge and discharge, if I understood the description of function properly. And what it doesn't say is how it rolls through the ranges. Like, does it test this, and if it doesn't work it moves to the next one, and then the next? We don't know. That's something that I don't know, at least right now. But I'm going to put my scope on here, and I'm going to see what this looks like. As a matter of fact, I'm probably just going to look at the collector of the TR15, and let's see what we have. So here's TR15, and the collector should be connected to the tab here, and I should be able to just connect my scope right there. And let's go up to here, and I have it rolling here, and let's see if we get anything on here. Oh yeah, getting some very ugly looking pulses, but again, that could be my scope. Okay, and like I said, this is a ×10 probe, and these are little signals we're looking at. And look at those big intermittent. Again, I don't know if that's my scope aliasing or if those are actual noise spikes. I don't know. So disregarding the noise, we're getting the pulses on there. So I think this big one must be like a reset pulse, and then these little pulses are the actual test pulses that are being sent via the, by the current source, or for the current source, I should say. Again, I'm still learning this myself, so it's a little bit confusing to follow this logic, how this thing works. Okay, so we have our pulses here. So now let's see if we can read back through the circuitry, and we should see our pulses at IC23 pin 8, and then after we do that we should be able to read IC25. That looks like what, pin 6 or pin 5, something like that. Pin 6, I think. So let's do 23 pin 8 and 25 pin 6. So IC23, that would be pin 8, which would be this one right here. So I'm going to look at that. Let's get up on the scope. And again, this is going to be noisy partially because of the scope, partially because of the 10x probe, and everything's out in the open. Don't worry about that. Okay. And if I push the read button, and look, there's your pulses again. Okay. And then I want to go to IC25 pin 6. Let me see if I can find IC25. Okay, pin 6. That's going to be right here. Oh boy, look at that. What is that all about? That is a big old ugly signal, and that's a 6 megahertz signal. So IC25 pin 6. Let me go to pin 5. Maybe I'm looking at it wrong. Okay, and there's nothing on pin 5, and if I hit value, and there's no pulses on that either. Alright, so IC25, how about pin 4? That's the output, and that's high. And there's nothing. Alright, so let's look at that logic a little bit and see why it's doing that, and if that's correct or not correct, because I don't know. Okay, looking at this, IC25 pin 6 goes up here, and if you follow it around, it goes back and ties into your 6 megahertz clock. So that's your clock. And then pin 5 is the actual signal here. And those are going through this op amp down here, the LM319, and we should see when this gets ANDed together with this, we should get an output of 6 megahertz pulses that follows along this, I would think. I don't know. Okay, so here is IC25 pin 6, which is our clock, and we have our clock. Here is IC25 pin 5, and I may have to slow this way down. Oh, what am I doing? Never mind. Tony's using the wrong thing here. Wait. All right. And there's absolutely no signal here whatsoever. You see that? Even if I roll it really slowly, let's see if we get a pulse. And there's nothing. There's nothing on pin 5. How about pin 4, which is the output, and it's constantly high because it's a NAND gate. So that tells me we're not getting anything out of the LM319. So let's go back to the LM319. Sorry, I'm thinking out loud and I might not be describing things correctly, but we were able to see something here. And the camera is drifting. Okay. So let's go on to the LM319, which is IC27 pin 4 and 10, which are tied together. Let's look at that once again. So pin 4 of IC27. IC27 is right here, and let's look at pin 4. All right, 1, 2, 3, 4, and nothing, absolutely nothing. So why? So let's go back to, again, IC23 pin 8, if I'm reading that correctly. IC23 pin 8. So IC23 pin 8. And I'm getting pulses on that. Why is that? So if I go up here, yes, they are very small pulses and they are negative going, but they are there. So if I go pin 8 of IC23, you see them? And of course, if I change the voltage scale, you'll see them more prominently, but bottom line is, if that is supposed to be tied, I mean, you look at the schematic, those are the same point. See, this was driving me crazy about this schematic. So if I'm actually seeing something here through this is just a voltage follower. If I'm getting something out of here and I can measure it, why does it not show up here on IC27, pin 4 and pin 10? Doesn't make any sense whatsoever. Okay, so pin 8, 9, 10. Let me try it on pin 10. I'm getting it on pin 10. Here, let me show you. Why am I getting it on pin 10 and not pin 4? So here is pin 10. See it? There's the pulses. But if I go to pin 4, nothing. Now, correct me if I'm wrong, everybody, but unless I'm reading the schematics incorrectly or the print is so small that I'm missing something, pin 4 and pin 10 are tied together. So why am I seeing it here and here but not here? Wow. So do I have a bad schematic again? Another bad part, mistake? Or is there something wrong in the board? I don't know. Put my mic on. Okay, so I ohmed out every single pin of IC27, and sure enough, these two pins are definitely tied together. There is definitely this diode across here that you can read. Everything looks good except pins 4 and 10 are absolutely not tied together. So do we have a broken trace? Do we have a misprint on the board? What exactly what is the problem? Why are we not getting that signal to that pin? So part of me says, jumper the two pins together and see what happens. I mean, you've got nothing to lose right now. I don't think it will hurt anything to try that. And even if it does, we can replace the chip because it's just an LM319. So 4 and 10 it is. Okay, pin 4 and pin 10 are jumpered together. Here goes nothing. Let's bring this up so we can see what happens. And so you can see the smoke. I do have a capacitor still connected, but I did not zero the leads, but let's push it and see. Dude, it reads. Okay, let's try let's try zeroing the leads again. So open. All right. Short. Okay. Now let's go over to here. It's saying 431 picofarads. Now it's a 1500 PF cap. So now let's see if our potentiometer works. Because we're supposed to be able to hold this down and adjust it. What was it? R55. We should be able to get it to read 1500 picofarads. Let's see what it does. Oh yeah. Now it's not. It's only moving it a little bit. It's off, but it is reading, and it does adjust now. Okay. Oh, good heavens! What does this mean? I'm stumped. How can this many things be wrong? I mean, that's not the chip. That's actually a physical connection on the board, and it doesn't appear as if that chip has ever been touched. It looks factory. I don't know. I'm gonna have to think about this for a minute, and I will be back. Okay, let's take this a little bit further now that I've thought about it. Let's do our open calibration. Let's do our short calibration. Okay. Alright, so I'm going to measure this 1500 picofarad first. You can see it's off by a lot. I mean, it's measuring now though, which is good news, but it's off. let's take a different capacitor that's going to force it into a different range. I'm going to put a 100 microfarad, so that should take us to the, let's see, you know what, before we do that, let's try, let me see if I have a, let's see, a 10 microfarad. Okay, so here's a 10 microfarad. Let's connect the positive and negative. Let's see where that is, because that's a different range and that's going to be a different current source. All right, test. 6 microfarads. That's actually, it's reading just a little bit above half, it seems. Here's a 100 microfarad. That's also another range. So here, 100 microfarad. And it's 64.7. So you can see they're all reading just a little bit above half. And I still have this really leaky 2200 microfarad on the bench. Let's see what it reads. And that's going to be the highest range it's going to measure. And it's close. It's reading almost 2100 microfarads. So the highest range is not that far off, but the other ranges are about half of what they should be. The good news is, though, it is working with that funky little jumper sitting up there. Why in the heck would that be? How could that be like that? I just can't figure it out. So I think the next thing I'm going to do is I'm going to pull this board again. I'm going to remove that integrated circuit, and I'm going to see if there's any damage around on the traces or somewhere where we're losing that connection. Because obviously, if I disconnect that and I put this, let's put this 100 microfarad back on here again, just like that. If I take this jumper off of here, I'm just removing it, and I hit value, and again, it just doesn't read a thing. Nothing. Error 7. Out of range. So it has to have that jumper on there. It won't work without the jumper. Put the jumper back on. It reads. I don't know. Okay, I'm not really sure what this is all about, but look at all that glue down there. And if you look on the bottom of the chip here, there is some serious glue on this thing. I don't know if that damaged the track. I'm going to have to really look at this under a magnifying glass. You can probably see it better than I can right now because I'm focused in here so far. Come on. Well, I was. There it goes. So you can see, I don't know. Maybe there's a broken trace, because there's the trace that goes from pin 4 to pin 10 right there. And look at that right there. Maybe that is a little crack right in there. I don't know. So let's take the meter before we do anything else. And let's go on to ohms. I'm going to back up a little bit so you can see what I'm doing. And I'm going to go from here, which is pin 4. That, if I can get on it around this camera, to pin 10. And you could see it jumped for a second. And if I go back in here, I think there's a loose connection in here someplace. Yep. This trace down here, right here. So let's clean this off. And before I do that, another word about this. One of you viewers brought this up, and I'm glad you did. When I talked about having your body be at the same potential as chassis ground, that is in fact what this does. However, inside this strap, or inside the ground over there, there's actually at least a 1 mega ohm resistor. Okay, and what that resistor does is it'll allow the static to discharge, you know, from your body to the ground that it's connected to. Of course, this is connected to the ground prong of the power cord, but it will do so through that 1 meg resistor. So if you do get in contact with something that's live, you are not connecting your wrist directly to ground and to that live thing, but you're limiting the current that you can be shocked with through that 1 mega ohm, or sometimes even bigger than that, 2.2 mega ohm or so resistor. So don't ever connect your hand directly to earth ground when you're working on live circuits, because if you do get across something, now this is all low voltage stuff, but if you remember, that high voltage supply on here can go up to 1,000 volts. You're still going to get a bad shock, but if you were directly connected to ground through this, you could get really messed up. So thank you for the viewer who mentioned that, because sometimes I talk as if you all know everything, and I forget sometimes people might not get the whole story. So that's it. And all of these, even the cheapest ones you buy, typically, I've never seen one that has not had a resistor between the wire that's going to go to ground and the little pad here that goes onto your skin. So just so you know. Okay, I think we found the problem. First of all, if you look at this resistor here, you can see somebody had lifted this leg and then soldered it back in. See that right there, the little solder blob? But anyway, if I go right onto the pad of pin 4 and I go over to pin 10, I get nothing. You see that? But if I go just slightly back here on this exposed part, right in here, look at that. Bad trace. How about that? Who would have ever guessed that? Now, I'm not going to try to fix it on this side. I think what I'm going to do is I'm going to put some bus wire on the other side of it and jumper it on the rear of the board instead of the front. Okay, I'm using this insulated bus wire to make the jumper on the back of the board. You can see I just kind of stripped it and just wrapped it around the pin. I'm going to clean the tip really well. And I'm going to come in here very carefully and tack that on just like that. And that's what it should look like when it's done. And I can go clean these ones up. So this is pin 1, 2, 3, 4, and then 5, 6, 7. Okay. I need to just touch this one a little bit more. And then 8 is already done because I soldered the 4 corners. Pin 9. And then number 10 is right here, so that's where we want to put the other side of our jumper. Okay, let me put this back in here. This is very touchy. Even with all the lights and all the little pliers and things, very, very touchy. You could just lay the wire across there if you want, but I like to get a mechanical connection on there as well, if I can. And, oh, I had it and then it fell off. There it is. Okay. And I'll push this down. This is going to make for a long video. Okay, clean the tip. Get this on here. And there we go. And we're going to go through and finish the rest of these. And yes, you can use a smaller tip, but I'm used to this chisel tip. I have the pointy ones, but I actually like this better. I'm just used to it. So, all right, there you go. Now what we're going to do is we're going to, again, clean this off with some alcohol. I mean, it's going to leave that little smear mark, but hey, it is what it is. All right, and we'll get a dryer. We'll dry it off a little bit. And it should look pretty good. Okay. Still a little bit wet, but when that dries, that'll be perfect. Okay, so 1, 2, 3, 4. Right there. 5, 6, 7, 8, 9, 10. So there we go. 4 to 10. Looks good. And there's the front. Okay, here we go again. Let's see. All right. So let's do the open. Uh-oh. That's not good. It was working a minute ago. Okay, let's make sure we have everything connected, because it was working before we changed that chip. Let's make sure we have everything correct in there.